Junior High School Math. Based on the Japanese textbook, revised in 2025. In this course, mathematics, taught in Japanese junior high schools, is explained in English. It is designed for Japanese students who are considering studying abroad. But by using subtitles, it can be viewed and understood in any language around the world. Chapter 1. Expanding the World of Numbers. Section 1. How to express numbers. In elementary school, we learned about whole numbers, decimals, and fractions. We also learned how to use them when expressing numbers, performing calculations, and so on. Whole numbers are numbers without fractions or decimals. They are 0, 1, 2, 3, 4, 5, and so on. Decimals are numbers that include a dot or a decimal point. In English, the examples are read as 1.5, 3.14, and 0.75. It's not 0.75. You read the numbers individually after the dot. Fractions are numbers that are expressed with a numerator and a denominator. Fractions in the example are read 1/2, 3/4, 3/4, and 2/5. You first read the numerator as a regular number, and then denominator as a no-denom number. If the numerator is 1, you read the denominator as a singular ordinary number, and if not, you'll read the denominator in plural. Alternatively, you can read fractions using over, and just call them 1/2, 3/4, and 2/5. This way is easier when dealing with large numbers. First, let's think about this. We will line up square tiles of equal size, without any gaps, to make a rectangle. 1. When we use 12 tiles, what kind of rectangle can you make? Then, you may come up with a rectangle like this, or the same one, just rotated sideways. Or ones like these. Now, when we use 13 tiles, what kind of rectangle can you make? When you were given 13 tiles, you cannot make any rectangle other than these. Because, with 13 tiles, some tiles don't fit in. In this video, we are learning how to express numbers, and we are going to start with prime factorization. Let's think about a similar question to the previous one. Express 12 and 13 as products of natural numbers. Before getting to the main point, we need to know some new terms. One is natural numbers. They are counting numbers starting from 1. They are 1, 2, 3, 4, 5, and so on. Some people say that 0 is included in natural numbers. But in junior high schools or high schools, natural numbers usually don't include 0. And the other is integers. You need to be very careful about the difference between integers and whole numbers. Integers are whole numbers and their opposites. That is, positive numbers, negative numbers, and 0. This figure shows the types of numbers you usually learn in elementary school. In elementary school, the world of numbers were quite limited. We only had whole numbers, decimals, and fractions. However, in junior high school, we start using some new terms such as integers and natural numbers. And instead of using integers, we really use whole numbers. we will learn some more new terms in the future, so it is recommended that you understand the meaning of each term clearly. Let's continue on the question. If we ignore the order of multiplication, how can we express 12? The answer is very simple. Starting from the smaller numbers, there, 2 times 6, 3 times 4, 1 times 12. On the other hand, 13's factorization is only 1/3 13. By the way, you cannot express the rectangles on the right with simple multiplication. From 1 and 2, you can tell the difference between 12 and 13. And that is, 12 is a composite number, which has several factorizations, while 13 has only one, and 13 is called a prime number. As shown in the figure, composite numbers can be divided in multiple ways, while 13 cannot be divided any further, except by 1 and itself. Here's another new mathematical term that you should learn. That is prime number. A prime number can be expressed only as a product of 1 and itself. You should note that 2 is a prime number, although some people tend to mistakenly think it's not, because it's an even number and divisible. However, just as the definition says, it's a prime number for the same reason. And then, some might think that 4 looks like a prime number, but it is not, as it is clear that 4 has more than 2 factors. 1 is not considered a prime number, as prime numbers must have 2 distinct positive factors. 1 has only 1 as a factor. Now, let's review the concept of numbers here. We've newly learned about natural numbers and integers. As you can clearly see, prime numbers are always natural numbers. So prime numbers are included in natural numbers. Now, you should be able to tell the difference between all of them. Here, let's check your understanding. Is 17 a prime number? To answer this question, think about which number between 1 and 17 can divide 17 evenly. If you know simple multiplication, you can instantly see what factor 17 has. It's only 1 on itself, so you can say 17 is a prime number. Next, let's list all the prime numbers less than 20. By definition, you can exclude 1 right away. For other numbers, if a number can be expressed as a multiplication using other numbers down 1 and itself, you can say it's not a prime number. So, 4 is not. 6 is not. 8 is not. It goes the same way. And down. All the other numbers are the prime numbers. Now you have all the prime numbers less than 20. We are getting closer to the main point. Here, we are going to think about how we can express 42 as a product of natural numbers. As you learned the multiplication table in elementary school, you might come up with 6 times 7 as a product. In this case, 7 is a prime number. so 7 is called a prime factor. On the other hand, 6 can be divided by other number than 1 and itself. You call it a composite number. That can still be broken down to prime factors. When the factors are all prime numbers, you've performed prime factorization, which is the theme of this video. Here, we started dividing 42 by 6, but you can start dividing it with other numbers, say 2. Then you get 2 times 21. You can factorize 21 as 3 times 7. So finally, you get 2 times 3 times 7. Like this, you always end up with the same prime factors, no matter which numbers you start with when dividing a composite number. Now, let's practice factorizing other numbers into prime factors. You will learn how to conduct prime factorization following the steps. First, begin factorizing with the smallest prime number possible. For 30, it can be divided by 2, as it's an even number. Second, try the next smallest prime number. When you see 15, you might come up with 5, which is okay as a calculation, but mathematically, it is better to arrange numbers in ascending order. So let's write 3 here, and you get 5 as a quotient. You repeat the steps until the quotient is a prime number, but you already have it. So the answer is 2 times 3 times 5. The other ones can be easily solved this way. Now, you need to learn about yet another new term, power, here, so that you can perform prime factorization completely. Power is a number that shows how many times it is multiplied by itself. Let's see actual numbers. 5 times 5 is written this way. It's read as either 5 squared or 5 to the second power. When it's 5 times 5 times 5, it's 5 cubed, or 5 to the third power. 5 times 5 times 5 times 5 is 5 to the fourth power. By the way, you have to be clear with what part is called what. This whole thing is called power. And the small number that shows how many times we multiply the same number is exponent, or index number. In this power, the larger 5 is called base. Exponent tells how many times the base is multiplied by itself. Let's think about prime factorization, including exponents. Factor 126 into prime factors. 126 can be divided by 2, and you get 63 as a quotient. And 63 can be divided by 3, and you get 21. 21 can be divided by 3, and you get 7. And 7 is a prime number, so prime factorization finishes here, and you write the answer. 2 times 3 squared times 7. Do not forget to practice in drills, as it enables you to calculate fluently. Eventually, you will be able to calculate quickly and accurately, without much effort. So here, factor those numbers into prime factors. Do not forget to read them out. 90 can be divided by 2 and 3 and 3 and 5. So 90 equal of 2 times 3 square times 5. 72 equals 2 cubed times 3 squared. 108 equals 2 squared times 3 cubed. In this section, you have learned how to express numbers. Specifically, you have learned how to categorize numbers, and the numbers can be expressed in factorized form. Once you understand these ideas, you can perform more complex calculations in the lessons ahead. This is it for this section. See you in the next video.